Okay. All right, guys, I'm going to look at number 4 on the practice test. Before I do, though, let me ask you something that'll help us out with one part of this. What? So, if I told you that 14% of people like lima beans.
Kidney beans.
Kidney beans, even better. 14% of people like lima beans. And you take 1,800 people. How many would you expect to like lima beans? 14% of 1,800. I like it. Now, how did they figure this out? Does it really matter for what we just did? As long as they figure this out, I can then do what we just did. It doesn't matter, really, where this came from, as long as it came from true work, right? You guys with me? Somehow that relates to part of number 4. Not the lima beans thing, but the work. So 4 says the average and the standard deviation of these test scores are this. It's normally distributed, thank God, so we can actually do something. Part A says we pick one student. So this is valid for the first few things because that is the standard deviation of individuals, right? When I take a group, I've got to change this. I've got to adjust it so it fits how groups are distributed. So part A says probably X greater than 315. So some of you guys had a little trouble determining. Now in this specific example, it should not have been a problem because I tell you it's normally distributed, so you know it's a normal distribution. You don't do N choose X weirdness, right? It's not binomial. You don't know success and failure here, right? So I draw the picture. What goes in the middle? 281.2. And I'm interested in 315. Why did I put it up that far? Because I did. So you don't have to worry about, I'm going to make tick marks in this. No, screw it. Just put it on the correct side and then shade the right way. This is just a quick visual to make sense of what the answer is going to be. I could. I totally could. As long as I didn't do this question, as long as I went straight to the next set of questions where I took a sample of 33, why do I then not have to tell you it's normally distributed? Because it's bigger than 30. As long as you take a sample of at least 30, or greater than 30, depending on the book here, it's greater than 30, then it's normal enough when you plot the means. They become normal enough. I like it. Now, real quick, this is always interesting. If I take a sample of 33 students, will the ages be normally distributed? Who knows? Shit. So what am I talking? I'm not talking about a single sample plotted. That's still each individual, isn't it? If I plot every group of 33 students, then their average ages will be normally distributed enough to use the z-score chart, for example, right? That's the idea. All right, maybe. So this first part, I don't care that I pick 1 because I told you it's normal. It started off normal. I don't need 30. It's just normal already. Sitting there being all normal. So to find this probability, if you draw the picture for yourself, you'll kind of remember what to do. How do I find that probability? Well, first I have to convert that to a... Because then I can use the chart. It's got all the answers on it. Sounds good. Right? I know it's normal, so I should think z-score chart probably. So z... How will I set that formula up?
X minus mu over standard deviation.
I like it. So it'll be 315
minus 281.2
over 34.48.
So we didn't have that on our formula sheet. Can I put...
Which part?
We did not have it set up like that. We had it set up if we were finding the percentage.
So I had this.
Yeah, can we put that one?
I had this.
Oh, did you put that?
Yeah.
Of course I did.
Oh, okay.
Yeah, and we had a discussion about
I don't know
if you
why.
could put something down here. I had this next.
Okay. I thought I must.
Yeah, please, your God, you better have that on the formula sheet.
Yeah,
And that if you really want to, but if I'm you, I wouldn't even put that.
okay, sorry.
It doesn't matter. They're both the same. So what did you guys get for that Z-score?
0.98.
Now, here's the big thing. If you do that, you're not wrong, but people will say, there, 90%, I'm done. And there's so much wrong with that. Number one is, hey, 98%. So some people do 1 minus this, and even that is not right because this is a freaking Z-score, right? And they kind of suck because they look like percentages. Stupid Z-score. It's not Z-score's fault. What do you want from me? You've got to tell yourself what the hell you just did. Don't say, I feel like I've done enough work. This must be it. I hate when people do, they get to this far and then they just circle it. I'm like, oh, shit. If you're not using the Z-score chart on this kind of problem, you're not doing it right. So when you look up 0.98, you actually get the area that's where? Below it. And I want the area above it, so we're going to man. So we get like
365.
So the actual answer, 0.1635. I like it. Because there'll be 1 minus this, of course, to get the rest. The whole thing is 1. If this side is 0.8365, this side must be 1 minus that. And let me let that sink in.
So you looked up 9.8 or 0.98 on the Z-score chart, which gives you 8365.
And I immediately put it below what I looked up.
That gives you the percentage.
The other side, the actual question is greater than. I like it.
That's percentage to 0.16.
Yeah. So 0.1635, or you can write it as 16.35%. Both the same thing.
In the test, you're going to more space.
Oh, of course, obviously. I did this to save paper. I figure you guys could do your work for this anywhere. Don't take this as a challenge. Right? Oh my God.
I just want to know if you can bring an extra paper just so I can...
No, I'll have it spaced out a little more. And you can always use other paper if you need it. Please. Yes. Bless you. Again, you don't have to. But the people that don't graph it are the people that will make the most simple mistakes. You just are. So if you feel like a gambler, I won't take points off if you don't graph it. But if you make a mistake and the graph would have helped me see what went wrong, you're going to lose more points. I have to assume the worst if I can't tell what mistake you made. Okay. Now real quick, I'm going to bypass, this is part 1 of A. Let me see if you guys can handle this, because I want to immediately do, there's a part 2, there's a part B, but look at part D1 real quick. Do you see how it relates to this question? So if we do these kind of together, I like it. Because this says take a sample of,
39.
and then it says what's probably that the average of those students is greater than 315. All the work should be the same. It's basically the same question. It's just that what part of what I used up here can I not use here?
Standard deviation.
Because this standard deviation is good for individuals. I need the one that's good for groups of 33. So I'm going to do all the same damn work, except this is not going to be. That's the only part that's different. So what's the standard deviation become?
6.
Yeah, catch it before the 4.48, divided by square root of 33. 6.002?
Yeah.
Not just 6. Dorky teacher, take points off. Dorky teachers. And now it's, I really want to see you guys understand. Same damn work, you gotta, please let it be that easy. Z equals 315 minus 281.2, but now it's divided by
6.001.
Is that where you get the 4 points of it? Right? What do you get? 30, yeah, 4 point something.
5.6.
5 point something. 5 point, who cares? So the chart officially says, in that case,
3.5.
this would be 0.9999 here, right?
Yeah.
That's what it says. It's silly, of course, because at 3.5, I agree with you. But once you're 4 standard deviations up, 5 standard deviations up, it ain't still 0.999. It's now it's 0.9999992 or whatever. So either you could do what the chart says, which is beautiful, which would mean what's your answer then? What's this side?
0.0001.
Bam. Which basically any human would say it's about 0%. Right? Or you could say it's about 0. Just straight up, if it's off the chart, that's about 0% out there, right? At 3.5, you've already passed 99.99% of all the data. So at 4.5, at 5.5, you've passed even more. So what's left out beyond that, basically 0, right? Yeah.
So 6.002 is the standard deviation.
Good.
And anything past like 3 standard deviations is beyond the 99.7.
3.5 standard deviations.
Right.
Is off the chart.
So the fact that it's 6 means why
Well,
equals around
our
0.
z-score was 5 point something. That's what's important.
Okay.
Standard deviation could be 18 billion. But the z-score could still come out to be 0.3, maybe, right?
Okay.
What's important is our z-score was so far. I mean, what does this say? What was the z-score exactly? 5.63, but that means that this score is 5.63 standard deviations above it. Holy shit. And what percentage of the data is within 3 steps for a normal curve? 99.7%. So if you're like 5.6 steps up, you passed everybody by. Except for a few little, yeah, that's why I say it's just about 0%. But if you put 0.001 because you're used to the book, or I'm sorry, the chart that I gave you, I'm okay with that. That's fine. Does that make any sense? I mean, look at the way this looks. We're basically here. What percentage is left? So small that most humans would say it's 0%.
Oh, I see. So that's the equation from 4a kind of, where you z equals...
Yeah, that's why I wanted to do that right away. I skipped a lot of problems, didn't I? I'm not saying you don't have to do them. I'm just saying that's the exact same question as this, except they're asking about a mean of 33 students. So everything's exactly, all the work's the same. I just couldn't use this standard deviation because that works for individuals. I needed the one that works for groups of 33. Yes?
So part B.
Okay, let's do...
Okay.
Is it very cool? The second part, if you got the first part, you got the second part, right?
Mm-hmm.
I'm going to give you the answers here in a minute anyway. Number 2, that probably 274, less than X, less than 292. Change them both into Z-scores, look them up. Is that cool? I'll give you the answer key. Part B, that's why I just did what I did earlier. The very first thing before I did anything was the percent liking lima beans thing. And you're all like, here he goes with this freaking lima bean shit. And Brussels sprouts, lima beans, what's this problem, this guy? This guy's problem with vegetables. Look what Part B says. If 2,000 students are randomly selected, how many would be expected? Am I asking you about a sample mean? A lot of you guys try to start changing the standard deviation. That's crazy. You change it when I take a sample and I ask questions about the sample mean. How many would be expected to have a test score greater than... Well, what percentage would be expected to have a test score greater than 315? 16.35%. And if I have 2,000 students, how many would I expect to have a score above 315? 16.35% of 2,000. Bam, done. Quick, easy. Just like I said earlier, whatever way to figure out the percentage you like lima beans, I can take that percentage of how many people I'm looking at. So what do we do to figure out this percent? A lot of work. But I know the percentage. So I can just do that percent of any number of people. That's how many I expect. On average, right? Okay, maybe. You guys love that question, right? What about part C?
Is the answer for B?
I don't know.
7?
3, looks like it's 320 something.
32,700.
No. 0.1635.
Oh yeah, you
327.
327? Yeah. Okay. Part C, top 5%. I'll be up here. Of course, we have to look up 95% because the chart only understands areas that are below. Now, if you look at 0.05, you just take the negative off. That's a shortcut, you know. Maybe. So what do you get when you look up 0.95? What's the z-score you get? That's the special one with the asterisk. 1.645. And I want to know the test score that puts you there. So how do you change that into a test score? If I take a z-score and make it back into a raw score. Yeah. So whenever you start with a percentage and you want to work your way back to a raw score, age of dogs, size of shoes, whatever, right? Test score in this problem. You've got to use this formula to get back to it. It's really just the z-score formula reworked because you're going the other way. So now you just put in there, what do you got? 281.2 plus 1.645 of these. This is before we did the select 33 students, so that hasn't changed yet. Is that cool? And then whatever that is?
337.9196.
Yeah, 330 something? Maybe? Okay. And then part D is basically the same. So let me give you the answer key. This will be interesting. My beautiful scribble. Like Donald Trump. My scribble's the best scribble. People in between you? Yeah. Or just one? One, okay. So you're right there. In front of you?
Yeah.
That's Friday, right?
Show how to solve it on the
Yes.
This is So for 5A, is it P of X equals 22?
You know what I would
Is
do?
that what we're finding?
Yes, 5A is exactly 22, so x equals 22, yeah.
Probably really bad time to bring this up since I was late today. Are we doing anything on Friday? Because I can't.
Yeah, of course we are.
Okay.
I don't know what.
No, I mean like any like a test or
Possibly a quiz, we'll see. Whatever
side
we go over on
make
Wednesday.
up, whatever happens.
Well, I mean, if it's a quiz, your next test grade will just take the place of that missing quiz grade. So it won't be 0.
Oh,
Your
really?
next test will just count higher. Yeah.
Oh, I thought we actually got to like miss it.
No,
Okay.
that's too much to keep track of.
Okay.
Yeah.
Cool. So just whatever you know, test.
Yep, it'll count in place of the missing quiz.
And then when is our final? Friday of next
The
week.
following Friday, yeah. Friday next. Yep. Yeah, dude.